Okay, get started. All right, so today we're going to look at another rule called the chain rule. And the chain rule is specifically for differentiating composite functions. Okay, so what is a composite function? That is a function within a function. So we only have one rule today, the chain rule. And so it looks something like this. When you have a function within a function, so it is the derivative of f of g of x. Right, so that's what it initially looks like. So the rule is you take the derivative of the inner, so that's going to be your g of x, so that's represented by this one right here. And then you're going to take the derivative of the outer, which is your f, and then you're going to have the inner in it. Okay, so that's this. So then it comes out to be f prime of g of x times g prime of x. So that is the rule, and a common error is when you take your derivative of the inner and then the derivative of the outer, and then you just composite them together. Okay, so an error would be taking the derivative of the outer with the derivative of the inner in it. Okay, so in words, this is how it's stated. The chain rule is the derivative of the outside function evaluated at the inside function times the derivative of the inside function. All right, now, if I had given you something like this, maybe to say like the second power, it's very possible to just multiply it out and just FOIL it through. But how about a 60th power? Just give up, right? If you didn't know the chain rule, I would give up too, because you would have to take this thing and do it 60 times and then FOIL it all out, which is kind of ridiculous. Okay, so we're going to apply the chain rule on this. So I'm going to make a template like we did with the product and the quotient. And so I'm going to first of all start off with the inner function. So the way that you get the inner function is you kind of just use your finger and cover things up. So this 60th power I'm just going to cover up. And what is inside this parentheses, that's going to be my inner. So I'll call that as my g. So my g is going to equal 2x squared minus 4x plus 1. Right, and then you'll just take the derivative as you normally would and put it right underneath it. So this will be my g prime. So that comes out to 4x minus 4. Okay, so now whatever you called as your inner, you just cover it up. So I'll take my thumb and cover that up. And then my outer is going to be f is equal to, and then it'll be this. I'll just call it a something. Something raised to the 60th power. Okay, so just leave it blank for now, but that would be your outer is something raised to the 60th. Now I'll take that derivative, so it's going to be f prime equals. So what is something raised to the 60th power? 60. And then when you write this next part here, make it large enough because eventually we have to put the g in here. So this would be to the 59th power. Okay. All right, so now I'm going to highlight some things here. So this right here is going to become this right here, because what is stated right here is going to be stated here. And I don't really have to fill this in, but this is going to be your g function. And what is the g function? Then you have to write out what it is and then put it right here. So that'll be your 2x squared minus 4x plus 1. Okay, so once you have that, it's actually a lot less complicated than f prime g plus fg prime or the quotient rule. You just take this right here and multiply it by this, and that's your answer. All right, so I'll just be taking g prime and f prime and then multiplying them. So then I get y prime is equal to, I have my 4x minus 4, and then I multiply that by 60 times the quantity of 2x squared minus 4x plus 1 raised to the 59th power. So I'll just label this. So this right here is my g prime, and then this right here is my f prime of g. Right. So then that's what I have here. So it's kind of swapped around, but this is multiplication, so it doesn't matter which one comes first. So I have this, and then I have this part right here. Okay, and then usually it's you'll want to put your constant out in front. And then 4x minus 4, I could probably do what with that? Yeah, take out a 4, so I can just make it, clean it up a little bit. So y prime equals, if I take out a 4, so that'll become 240. And then I have, from this, I'll have an x minus 1. And then this, you could just rewrite it as 2x squared minus 4x plus 1 raised to the 59th power, which is far better than multiplying it all out and trying to use another rule. Okay, so that's the answer. Yep, you just leave, and it's nice because it's already in the nicely factored form. Okay. Yes, question? All right then. For the next one, we want to rewrite it initially because if you leave it as 1 over this, you would have to use what rule? Quotient, right. So quotient, you should just try to avoid that if possible. So how can I rewrite it so it's something raised to some power? That's right. So 2x to the 5th minus 7 raised to the negative 3rd. So that's kind of the friendly form of it. And now I'll set up my template as I have up here and then figure out what my inner and my outer is. So I just cover up this outer part here, and what is in parentheses is going to be my inner, so I'll call that as my g. So g is equal to 2x to the 5th minus 7. Take that derivative. G prime is equal to 10x to the 4th power. Right? And then your f is going to equal, so I cover up what was my inner, is that, and it'll be something raised to the negative 3rd. So it'll be a parenthesis. So your first parenthesis, you could just make it small, because I know it's going to be my g function. So it's to the negative 3rd. And then when I do my f prime, you'll want to make it longer because you have to fit g back into that. Okay, so what is something raised to the negative 3rd?
Negative 3.
Uh-huh.
Then the g function to the negative 4.
Good. Exactly. Okay, so then you start filling stuff in. So right in here will be this one right there. Right. So then putting that in, you'll have your 2x to the 5th minus 7. And then your answer is just going to be, I'll just put it in pink, it's just going to be g prime times f prime. But really f prime is f prime of g. All right, I just didn't put it in there and label it. So you just take these two and multiply it. And so in order to get my answer, if it's negative power, it'll drop down to the denominator, and then I'll just multiply things together. So then that'll give me y prime equals, so what goes up to the numerator? I'm just multiplying these two. 10 and the negative 3, right? So that'll be a negative 30. And then the x to the 4th will stay up in the numerator. And this is going to drop down to the denominator all over quantity 2x to the 5th minus 7 raised to the 4th. Now you could take another step in order to write that. So you could just write this out exactly how it is. Keep your positives up in the numerator, or power, and then the negatives you can drop down. All right, and then for this one, it looks like there's nothing to simplify. Okay, how's that? Good so far, right? Okay, so now we get more and more challenging because you guys can handle it. All right, how about this one? How can we rewrite it? So I'm going to rewrite it as y equals. So first of all, rewrite everything so it's easy to take the derivative. What can we do there? 1, okay, rewrite this. What's 1 over x in a friendly form? X to the negative 1, and then instead of having a square root, I'll want it as what? To the 1/2 power. Yep, just like that. Okay, so now I'll do my template. So my inner is going to be my g, so that'll be 1 plus x to the negative 1. And then that derivative is g prime, so that will go away. And then x to the negative 1, use your basic power rule. So it's negative x to the negative 2 power. And then my outer is going to be f, which is this something raised to the, and then the power is going to be a half. Something raised to the half. Okay, so then my f prime is going to equal 1/2. And then I'm going to just rewrite my inner part as the previous, instead of having an x to the negative 1. The only reason I did that was to take the derivative easily. So then this will be a 1 plus 1 over x. And then it's going to be raised to the, subtract 1, so it's negative 1/2. Okay, so now I just multiply these two. For this one, I'll just say what it is, just write it exactly how it is and then simplify. So I have a negative x to the negative 2 and then I'm multiplying that by a 1/2 times the quantity x plus 1 over x raised to the negative 1/2 power. All right, now I need to clean that up because definitely they're not going to have that as the final answer. All right, so what belongs upstairs?
1/2.
A half?
Or just the one. Yeah.
So I guess just 1. Okay, 1 is upstairs, and then everything else is downstairs? I need to account for this negative here though, so I'll just put the negative out in front here. So then this will become an x squared, but I have a 2, so it's 2x squared in the denominator, and this one just drops down. And don't worry about this one being a fraction, just leave it as it is, so that'll be x plus 1/2, or 1 over x, and then quantity, and then raised to the 1/2 power. Right. It would be actually a lot of work to try to simplify this and then bring it up. You'd have to multiply by the conjugate. They probably won't do that, right? So then that would be your answer for y prime. Yes.
Forget the x plus 1 over x, because there was 1 plus 1 over x to begin with.
X plus, let's see, x plus 1, this part here?
Yeah.
X plus 1 over x is to the negative 1/2 power, so I just made it drop down to the denominator.
No, but I mean,
No, why'd you get the x instead of
Oh.
the 1?
Oh, it should be a 1. Yeah, where did that come from? I just copied it wrong. Right? Yeah, I just copied it wrong. Thank you. Okay, so that should be a 1. 1, 1.
You gotta ignore the 1.
Okay, so now let's take a look at a trig function. So the derivative of tangent squared of x. So tangent squared of x is not written in a friendly form. So I'm going to rewrite it as tangent of x and then quantity squared. So you always want it so that it's something and then squared, and then you can figure out what's your inner and your outer. All right, so what would the inner be on this one? Is, just cover this up, so it'll be the tangent of x. All right, do you guys memorize your trig derivatives? What's tangent's derivative? Secant squared. So g prime is equal to secant squared of x, right? And then your f would be, the outer is something raised to the 2nd power. So then you get your f prime, and that'll be 2 times, and then you put in your g, so that'll be the tangent of x, and raised to the 1st power, so I don't need to write anything. So now my answer is this times this. So then you get your y prime equals 2 times secant squared of x times the tangent of x. Or you could reverse those around and say 2 times tangent of x times secant squared of x. Did he have a test today? Hey, Jake.
Yeah.
You okay?
Yeah.
Okay, okay. I'm really tired. That all got recorded too. Okay, so for this one, you have cosine cubed and then of x squared. So this one is actually now more of an extension, so y is equal to, so you have cosine of, and then you have an x squared, and then all of that is to the 3rd power. So this is a triple composition. So all the previous ones, they were double composition, so we could think of these as 2 chains, and this one here as a 3 chain. Okay, so I'm going to just give you the general formula for a triple composition up here. So if you could write this down. So this will be, the derivative of a triple composition would be f of g of h of x. And so it's actually hard to figure out how many parentheses I need. There. Okay, I think that's enough. Okay, so it's kind of similar to what we did here. So for a double chain, or just a double composition, you have a inner derivative, and then you have the outer with the inner in it. This one, you're going to start off with the innermost. You have a 3-layer on this one. All right, so what is the innermost function on this? H. So I would say h prime of x. And then you move on to your middle. So you have your middle, which is your g. So that'll be g prime, and then you need your inner in it. So it'll be g prime of h of x. not h prime, but h. So that's my inner middle, and then my final one is the f, so this will be f prime, what do you think goes after that?
G of H of X.
Yeah, g of h of x. That's the derivative. Okay, so this is your inner derivative. I just put a little dash. All of this is middle. So now we're going in layers here. Middle derivative. And then this right here is the outer. And of course, any of these could be swapped around. So you could say outer, middle, inner, or inner, middle, outer. Okay, so that's the scenario that we have for this next case. And so I'm going to have a 1, 2, 3 column on this, right, instead of just 2 columns. Okay, so now let's get back down here. Did everyone get that? Oh, go ahead. I know there's a lot of, yeah, go ahead.
How do you identify if it's like a double or triple chain?
Well, so if you look at the function like this one here, within this there isn't like another function within that. So this is just a one inner and then the outer, and that's it. So all of these so far has just been 2 things. And so let me just point out for the one that we're looking at. So what would be the innermost on this one? Yeah, it's x squared. So I'm going to use my finger to cover it up. So that's the first one. What would the middle be? Yeah, so I cover that up, and then I have this. So that'll be the cosine is the middle. And then what would be the outer? Cubed. There they are. Okay? All right, so let's start off by drawing it out like this. So I'm going to now start with my h, which is my inner. So h is going to equal x squared. And so the derivative of that will equal 2x. And then my middle is going to be my g function, and so that'll be cosine of something. So then the derivative of cosine of something is going to be a negative sine of, and then what do you put in there? It would be the h function. So that'll be of x squared. Okay, so that's my middle. And then my final one should be my f. So f equals, what would the final thing be? Yep, something cubed. Okay, so something cubed. So then it'll be f prime equals, now you have to make this next one pretty long because it's going to be 3 times something to the what? Second. Now what do you put in here? Yes, exactly. Cosine of x squared. Yep, just like that. Okay, so then my final answer is just going to be this times this times this. Just multiply all of them together and then just make it look nice. All right, so then what is my y prime? Y prime is going to equal, so let's see, I have a 2 and a 3 and a negative, so that'll make it as a negative 6x, right, all of that 6x. And then I have a sine x squared. And then this one here, you should bring this squared here back in between this. All right, so see how they wrote this one in between? So that's usually how they like to write it. So that'll be times the cosine squared of x squared. And there isn't a whole lot you could do with that. And so that would be. Okay, so that's an example of a triple chain.
So,
How is that? And you could do a 4 chain also. 5 chain. You could have as many chains as you want. Right? As many composition functions. Okay, then our last example on this is we're going to now go back to another previous rule. So this is a product, right? It's a product. And then within the product, you also have a chain. So you have a product, and then within each parts of the product, you have a chain. So this is a product and a chain together. Okay, so we're going to start off with the outer part, which is the product. So I'll do the product first. So the product rule, I call one of them as my f. So f is going to equal sine of 2x. And then the other one is my g, which is cosine of 3x. So now as I take my f prime, I have to use a chain rule. But I'm going to have so many templates here and there, but that's okay. So right? Lots of templates here. So I guess I'll just do it right underneath it here. And lots of F's and G's. So what is my inner on this one? 2x. So G is going to equal 2x. So then that derivative, G prime, is going to be 2. And then my outer is sine of something. So then F prime is going to be cosine of, and then what do I put in for that something? 2x. Okay, so putting all that together, the derivative of F is going to be 2 cosine 2x. 2 cosine of 2x. Okay, so it's kind of like doing two things, 2 times of what we've done above, and now I still have to do my G. All right, so how about for my G? So my G would be, let's see, so here I can say my inner, okay, so this G is different from this G. So this will be a 3x, and then my derivative would be a 3, and then F is going to be cosine of something, and F prime will equal a negative sine of, and then it'll be of 3x. Okay, so then I get my derivative on this will become a G prime, which is negative 3 sine of 3x. Okay, but I'm still not done. Yes, go ahead.
Is the derivative of sine cosine 2x for the F prime at the bottom?
This one?
No, the F prime at the bottom, the pink one.
So the derivative of sine 2x is 2 cosine 2x, because you have to use a chain rule. So I try to show the chain rule template on this.
Okay.
And then the derivative of cosine of 3x is negative 3 sine of 3x.
Question.
Yeah, go ahead.
For F prime, where F equals sine 2x.
Yes.
I got 2 cosine 2x.
Yeah, 2 cosine 2x.
Oh, okay, never mind. I was just reading it wrong.
Where did
Okay.
you come from?
This 2?
Yeah.
Because it's the derivative of the inner.
Yes.
So the derivative of 2x is 2.
Oh, okay.
So you have to do derivative of the inner, then you do the derivative of the outer with, this is the outer with the inner in it.
You have to use the product rule now.
Yeah, so we're not done. Now we have to do the product rule. Okay, so we just kind of set it all up. Okay, so what's the product rule? It is F prime G plus F G prime, and I'm going to use it on this. So it's basically this times this. So now I'm ready to write my final answer. Y prime equals, so I'll bring the 2, so that'll be 2 cosine of 2x times cosine of 3x. Cosine of 3x. So that's F prime G plus F G prime, so it'll be a minus. Minus 3 sine of 2x times cosine, no, times sine of 3x, yeah, 3x. Is that right? Did I mix something up? Wait a minute. Let's see, 2 cosine of 2x, cosine of 3x, that's right. And then it's plus, but it's minus here. 3 sine of 2x, nope, I think that's right. Yeah. I mean, you can swap these around if you want. If you can say sine of 3x times sine of 2x, that's okay. Okay, and then there's not a whole lot you could do. I can't factor anything out, and so then that would be your answer.
Wait, isn't it,
Yes.
the sine double angle formula?
It would be a double angle formula. I guess you could just do it on this, but don't bother with it. I think that's fine. All right, but let me stop my video and then I'll answer your question. I think that's the stuff. Hold on.